Dr. Nayak on stage. Yeah. We would like to start the function on an auspicious note. For this, I would like to request all the dignitaries to kindle the flame of enlightenment and officially inaugurate our event by lighting the lamp. I'm sorry, we don't have the lamp here. But we shall move on. As you're aware, Dr. Shailesh Nayak has recently been awarded the Padma Shri by the President of India, and in order to celebrate this, the Ministry of Earth Sciences has released a citation. I will now be reading the citation in full. Government of India, Ministry of Earth Sciences says, Dr. Shailesh Nayak earned his PhD in geology from the MS University of Baroda in 1978. He commenced his illustrious career as a scientist at the Space Applications Center under the Indian Space Research Organization, ISRO, later advancing to the position of a Director of Marine and Water Resources. He played a pivotal role in the conception, formulation, and execution of numerous national-level projects that leveraged satellite data for ocean color analysis, integrated coastal zone management, snow and glacier studies, and water resource management. His efforts in generating detailed information on the Indian coast significantly contributed to the development of policies for coastal zone zoning aimed at regulating coastal activities. He was deeply involved in the restructuring of the Coastal Regulation Zone Notification issued by the Ministry of Environment and Forest, Government of India. In May 2006, Dr. Nayak was appointed as the director of the Indian National Center for Ocean Information Services in COIS in Hyderabad. There, he established a state-of-the-art early warning system for tsunamis and storm surges in the Indian Ocean. This monumental task required directing, guiding, and coordinating efforts across many departments and ministries and 14 national institutes involving over 300 scientists. The system was developed and operational within a record time of 10 months at a cost of 125 crores. He was also instrumental in the conceptualization and development of marine GIS. Dr. Nayak's exceptional contributions have significantly enhanced advisory services related to potential fishing zones, ocean state forecasts, the Indian Argo project, and ocean modeling activities. Upon his appointment as the Secretary of the Ministry of Earth Sciences, MOES, Dr. Nayak spearheaded the initiation of several new programs, centers, and activities across various disciplines within the Earth system science, aimed at benefiting society. Amongst these initiatives were the Monsoon Mission, Air Quality Improvement, Arctic Research, Earthquake Research, Ocean Biogeochemistry, the Ocean Ecosystem Modeling, and including multi-hazard warning systems, marine resources, and Antarctic database organization and management, web and location-based services, building the HPC infrastructure, development of human resources, etc. Dr. Shailesh Nayak is a fellow of the Indian National Academy of Science, Indian National Science Academy, New Delhi, the Indian Academy of Sciences, Bengaluru, and the National Academy of Sciences, India, Allahabad, the International Society for Photogrammetry and Remote Sensing, and is an academician of the International Academy of Aeronautics, Paris. He has been awarded an honorary degree of Doctor of Science by the Andhra University in 2011, by Assam University in 2013, by the Amity University in 2015. Dr. Nayak is a recipient of the IGU Hari Narayan Lifetime Achievement Award in Geosciences 2013, and the ISCA Vikram Sarabhai Memorial Award 2012, and the Bhaskara Award for 2009 by the Indian Society of Remote Sensing, Dehradun. In addition to his remarkable academic and research contributions, Dr. Nayak holds significant leadership roles. He serves as the President, Indian Geophysical Union, Hyderabad, and the Indian Mangrove Society, and chairman member in the governing body, RAC, of various institutes. Dr. Nayak has published about 190 papers in international and national journals and has delivered more than 200 invited talks in national and international forums. Currently, Dr. Shailesh Nayak is at the helm of the National Institute of Advanced Studies, Bengaluru, as its director. He also serves as the Chancellor of the Terry School of Advanced Studies, New Delhi, the Editor-in-Chief Journal of the Indian Society of Remote Sensing, and is a life trustee of the India International Center, New Delhi. In addition, in recognition of his substantial contributions to science and his unparalleled administrative acumen, the Government of India has honored Dr. Nayak with the civilian honor Padma Shri in the field of science and engineering in 2024. This accolade not only celebrates his personal achievements, but also underscores the impactful research and dedication he has brought to his field, and more importantly, the Ministry of Earth Sciences, positively influencing society and the scientific community at large. This has been signed by the Secretary of the Ministry of Earth Sciences, Dr. Ravichandran. With this, we would like to present the citation, but before we do that, we would like to ask the dignitaries on stage to offer some remarks. First, may I please invite the Secretary of MOES, Dr. Ravichandran, to say a few kinds of words.
Padma Shri, Dr. Shailesh Nayak, Director NIAS, former Secretary, Ministry of Earth Sciences, Dr. Krishnan, Director IITM, Dr. Kamra, and distinguished colleagues and friends, very good afternoon to all of you. It is indeed a great pleasure to be here on this Earth Day. We are felicitating Dr. Shailesh Nayak for his well-deserved award of Padma Shri. I think Earth Day, you know that today the Earth Day theme is a plastic versus planet. I think we need to safeguard our Earth, and I request all of you to make awareness about the importance of Earth in maybe by avoiding the plastic and other things in the Earth. So I request each one of you take at least a few people to make them aware about the importance of the Mother Earth. Coming to Dr. Shailesh Nayak, so I know him maybe 2005 when we start planning for the 9th plan for the INCOIS. That's the first time he came. I met him maybe in the Pusa campus. We were discussing about the future plan of INCOIS. So he was instrumental that time when he was in SAC ISRO. He was giving a lot of important advice because he is the man. He brought the potential fishing advisory services, which is still operational at INCOIS. He nucleated that program, and he knows the importance of how to translate the science to services. In that aspect, he brought this potential fishing zone advisory. That is the first he started. Then he started, of course, the very important things about what are the observation requirements, especially he is also very instrumental in bringing the ocean sat for the ocean color and many other products from the ocean color data, ocean satellite. I think after that in 2005, I think he joined in INCOIS, and he spearheaded the INCOIS. That is the time he came in such a devastating time that after tsunami, I think immediately he has given a task to build the system for the Tsunami Warning Center for India. I think he made that remark very successfully with the coordinating with the industry, coordinating with the various ministries, and also with the INCOIS, and many people work together for the one cause. And we are, I think he was able to establish the Tsunami Warning Center very short time. It was really, it is now, still it is the world one of the best tsunami warning center for the entire Indian Ocean, not only Indian Ocean, entire globe. I think during that time, maybe we have started some of the observations on Argo and other observations. So he initiated, he encouraged us to start the modeling activities at INCOIS. I am fortunate to lead that, and the way he promote, the way he appreciate the people and give full freedom, free hand to every individual, and that gives us a lot of leverage there. We can do some better science as well as the services for the organizations. I think one quality is he leave it to you. and only you have problem, you come to me. Otherwise, it is up to you. That's a quality. I think from that time onwards, I could see that the leadership role in his. I think I remember that from college days onwards, I think he is a leader. I hope so. So maybe that has come to handy when he was leading the institutions of INCAIS. Later on, he moved to earth sciences. So he made a meaning for the earth sciences very aptly, and how the earth system together we have to integrate and work together, and various system how we need to integrate and how do we build together. I think all the institutions bring together, and he made a better ecosystem for doing the research in Ministry of Earth Sciences. I think there are many things I can go on tell him, because he is, I can say that I think he deserved this award and he got it. First and foremost, I congratulate on behalf of Ministry of Earth Sciences for this award. And I am sure that we are so proud of you for getting this award. And I don't want to take much of this time. And I request maybe some of the other directors maybe say a few words, and I will leave for some of the things for them. Thank you very much. Thank you very much.
Thank you, sir. May I please request Dr. Krishnan to say a few words?
Respected Padma Shri, Dr. Shailesh Nayak, Director NIAS and former Secretary Ministry of Earth Sciences, Dr. M. Ravichandran, Secretary Ministry of Earth Sciences, Professor Kamra, and all the senior scientists and directors of all the MOES institutions, friends and colleagues. I am very happy to welcome you all to this very important World Earth Day event and the talk delivered by Padma Shri Shailesh Nayak on the vision of earth sciences in the Amrit Kaal. And we have heard from everyone, he's such a eminent person scientifically, a great leader and also an institution builder. And we really have the pleasure and privilege of such an expert giving the talk on earth sciences in the Amrit Kaal. And this is a great honor. Thank you very much, sir. And personally, I also take this opportunity to congratulate you for being recognized with the eminently deserving Padma Shri Award. And our interactions with, have been many interactions with Shailesh Nayak, sir. And especially when I was there in the Center for Climate Change Research, he was a very strong motivation. He was the main inspiration and strong support. And one of the things he said, Krishnan, every year, same time of the year, you have to do an annual workshop, and which we did for 10 years when I was there, year after year. And he also thought of the Earth system as a big integrated system. You have to look at the atmosphere, the ocean, the cryosphere, and focus on the important points. He used to look at the water cycle, the cryosphere, sea level change, and these are the important points. And also he told, I remember that, when you make this downscaling, you just don't make all these state-wise, you start making it, you are going to have problem. Just lay the overlay map on that. I think these are all very visionary thoughts that he gave me at that time. And so the center has really nicely come up. And thank you, sir, for all your encouragement and support. And we are really honored to have you here, especially on this very special day of the World Earth Day. And with these few words, I will not talk more and take much more time. Thank you very much, sir, and welcome all of you.
Thank you, sir. Now I would like to request all the directors to say a few kind words. So we'll bring the microphone over to you so you can speak. First, can I please request Dr. Ramadas to say a few words?
Good evening. On behalf of NIOT family members, I would like to congratulate Dr. Shailesh Nayak on winning this richly deserving Padma Shri award. And when I first met him after he won the award, I told him, sir, we share it with you. We consider you as our leader, friend, philosopher, and guide. So we are so proud that you won this award, sir. And it's very difficult to talk about Dr. Shailesh Nayak because he is so well known. whatever I say, it will be a repetition. But I can tell some anecdotes. I have been seeing him as a scientist at SAC, later director at INCOIS, and secretary MOES, now director of NIIS. But I have not seen any discomfort in any of his roles. He is so comfortable in whatever he does. That is really amazing. And we used to meet him actually in his office. In another 5 minutes, he had to rush and meet Prime Minister. But he used to talk to me as though he has all the time in the world. He used to ask me whether I need any coffee or something like that and all. That kind of comfort with people and that ease he handles ministers, scientists, colleagues, anybody and everybody. That's really amazing. He was with us when we cracked the tsunami algorithm and we tested the tsunameters in our tank, and he was the first one to appreciate it. And I still remember his speech at Administrative Staff College of Hyderabad when we went for training there. If the 1 week or 10 days of training is on one side, his speech about taking people along and the importance of fairness, I remember. And finally, when I took over as the director of NIOT, the first thing I did was I called him and I asked him for tips. He laughed and said whether he was waiting whether I would call him or not. And he gave me really very valuable tips. I'll only give it to my successor later. But I really thank him for being really our leader for all these years. And sir, we expect more wonderful things from you. Thank you very much.
Thank you. Professor Chalapati, please.
Esteemed Professor Shailesh Nayak ji, Dr. Ravichandran, Dr. Krishnan, and esteemed audience, I feel very privileged to be here on this occasion where we are felicitating one of the luminaries in geosciences of our generation. Professor Shailesh Nayak's career is inspiration for anybody. He started as a geologist working on bauxites. Then he worked with a very eminent person, Professor Mayer, and he shifted to Professor Desai. He told me why he shifted. I don't want to say it here. Then he went to Space Application Center, became an expert in remote sensing and ocean studies. Then he went to INCOIS, took up tsunami modeling system as my predecessor narrated, and he went back to MOES, initiated also Koina drilling project. He gave tremendous support to it. Actually, the hydrothermal project, which NCPR is doing, is actually his initiation because I was in a committee where he made Professor Gaur as chairman, myself, Dr. Ravichandran, we all worked together for a year. I mean, the most important thing which impressed me is his positivity. He promotes anyone with a big smile and encourages people to do well. I mean, that's what is needed in the system. And I'm very glad that he got it. Very few handful of Earth system science people got it and he joins them, and I believe he deserves many more. And from NSES, we are always grateful to you, sir, because it was you who grabbed NSES from a state government department and made it a central government department. So we are forever indebted to you. I've gone through the science plan and how it was integrated. Dr. Ravichandran was there. And we are really grateful to you, and the whole NSES is celebrating your success. So he is a complete Earth system science man, started with geology, oceanography, meteorology, and also planetary system encouraged. So, sir, stay well and please bless us all. That's what I want to say.
Thank you. Dr. Srinivasa Kumar.
Thank you very much. Sir, respected Shailesh Nayak sir, Dr. Ravichandran, Dr. Krishnan, Dr. Kamra, and colleagues in the audience. It's such a privilege, sir, actually, and hearty congratulations from the INCOIS family, and then from my own behalf. INCOIS family includes you, of course. So you're our director actually since 2006 to 2008. So we congratulate you on receiving this prestigious Padma Shri award. And my association with you, sir, actually, it goes back, with sir, goes back 25 years, 1998. That was when I was working in ISRO in the Regional Remote Sensing Service Center. The IRS-P3 MOS sensor was launched, and then you were behind the whole thing, getting the data, processing it, and then that was the precursor to OceanSat-1 OCM sensor with 8 bands. And today the OceanSat-3 has 13 bands on the OCM. Every single step of how the sensor is designed, how the data should be, processed, the algorithms should be built to the, to the last point, last mile of how the data should be used for the society. I think he's behind every single step of these things. That's the speciality, sir, we've learned from you is actually whatever we do, this is what you taught us always. Whatever we do, it should be related to the society. It should have a societal benefit. We can do great science as scientists. We can publish, it's all good, but then it should have a relation to the society. We should be useful to the society. And that's what actually, that tradition we still continue, sir. And then, of course, the tsunami warning, everybody spoke about, Dr. Shailesh Nayak said that he established Tsunami Warning Center. That's 100% true. But then what several people do not know is how much effort he has put in actually bringing international recognition to the tsunami warning system. Those days there was this, the IOC-led framework, and then there was a lot of, discussion on whether we are still ready as a center to be able to handle the international, obligations that a tsunami warning center needs to have. And then at every single point in all the meetings, he used to actually push our case and say that, yes, we are ready and we need to be recognized. INCOI should be recognized as one of the tsunami service provider. And sir, in 2011, after the IOWave 11, INCOI was recognized as the first tsunami service provider for the Indian Ocean region. And thanks to all your efforts. And of course, Secretary also mentioned about ocean modeling and all those programs. We were very privileged to work with you on those things. Other great thing that we all at INCOI learned is basically, the management. How do we really manage things in a very friendly way? Because all that we do is so it is inter-institutional kind of. With the small manpower that we have, unless we actually collaborate each other with other scientists, other institutions, other international partners, we can only go that far. I think that was something we really learned from him. And the other big lesson which we still follow today is, handling these large projects. How do we really work not only with scientists, but with finance, with administration? That's one great thing actually. When somebody used to come with him to a file and said that, and he tells him that this rule, based on this, we cannot do things. I remember he used to say, please don't bring the rule book to me to tell you how things cannot be done. You please bring that to me to tell how things can be done within that framework. I think that's a whole different, the twist to how do we interpret rules. I think that's a great thing that we also learned from Dr. Nayak. Sir, thank you very much. I can keep on speaking, but I was told 2 minutes. I think I've already taken 5 minutes. But congratulations once again, sir. And then we will continue to, learn from you, take your guidance. And I also wanted to mention one last thing about how the tsunami modeling system was set up, actually. Those were the days when we knew that we can't run these models in real time. And then I was speaking earlier today in my presentation as well, that we run a suite of simulations, pre-run, and then keep it in the database. Now, this was a very new technique, and several people were not very convinced that that is the way we should do. But then when we went and explained this to him, of course, he had others that he had to convince, but he said, okay, Shri, your team, you go ahead and do this and then implement it, test it, and then let us, I think it is, he believed in us, basically. When a group of youngsters those days were telling that, sir, this is how this might work, then he believed in us, actually. That is something also we learned from you, believing in, youngsters and then taking everybody together. And today, even today, we use that system, actually. So thank you very much, sir, and then congratulations once again.
Dr. Ramanamurthy.
Good evening, all. Respected Padma Shri. I think I will remove all other things because now the new thing has come to him. Dr. Ravichandran, Secretary, Minister of Science, Dr. Krishnan, and colleagues. The first one which I would like to tell is, I think he always smiles. That's what same thing is there from his photograph also. Wherever he goes, we can see his pleasant face. That's what we call him as a pleasant mentor. My association with him started with, I think Dr. Sini was telling about when tsunami warning system was set up in Inkois, I was called for 2 days in a week to be there to customize the model for tsunami. That was my first interaction. But after that, NCCR, in fact, he has defined the new role for the National Center for Coastal Research when it has moved from the Project Directorate to National Center for Coastal Research. He has defined the themes, how we should go forward, and what to be taken. And one more thing which I remember from Dr. Shailesh Nayak is, sometimes back I used to tell him, sir, if I have to do for that, I need to have a power. No, Ramanamurthy, you are wrong. What you should have is the responsibility. Somebody should assign you a responsibility, then you can do and excel well. And that's what he has done in Inkois. He has identified many youngsters and then he has defined the task to them. That's how it has grown to that stage for that. There are many things to be learned from him, especially on the coastal regulation zone. I think in his citation also he was told for that. It has completely changed the entire country into different domain for that. Today, whatever we have, the notification 2019, which also balanced the environment but also promotes the development for that. Many things to be said for that, but last part is not only in the daytime. Once you go in the evening, he will tell you so many tips how you have to live yourself and happily and then move forward. I wish you all the best, and also on the behalf of NCCR, congratulate you for Padma Shri, and also expect many more things to come in. Thank you, sir.
Thank you, sir. Dr. V.S. Prasad, please.
Padma Shri Shailesh Nayak and Ravichandran and Krishnan and dear colleagues. And I congratulate Dr. Shailesh Nayak for getting the Padma Shri award. And I know him when I started career in NRSC. That time people are telling about him that PFJ things are started with him at NRSC. And also that time wash and color sensor, when we were discussing about the wash and color sensor, then that Shailesh Nayak name was very much there in NRSC. That is talking Dikshitul Garu and then other people are mentioning about him that we have to follow that good work. And after become secretary of MOES, then again we started interacting with him. And for a particular NCA model, that time we are thinking of UK Met Office model, go to that one or GFS, continue that one. And he has given clear guidance he has given to go to the UK Met Office, and we are seeing the fruits of that one. And UK Met Office program was developed and partnership with them. And another thing also, BIMSTEC Center. That the BIMSTEC Center, we are a lot of meetings are going informally, and there is no formal setup for that one. And under his secretaryship, we had the formal BCWC program was inaugurated, and then we had the building for that one, and the project work is going on. And now still that BCWC becoming even India Center. Prime Minister also announced that one many programs for the BCWC. We are continuing all UM and BCWC works, what he initiated. We can answer that.
Thank you, sir. Can I please ask Dr. Gupta to say a few words?
Padma Shri, Dr. Shailesh Nayak ji, Secretary Ramanamurthy, Ravichandran ji, Krishnan ji, and good evening to colleagues, everyone. In fact, today I am sitting here as a Director CMLRE. Is one way it is Dr. Shailesh ji is responsible. In 2009, when he has identified me as a potential candidate to do the biogeochemistry, which is a vacuum in the CMLRE, and he asked me to move out from ICMAM, then Project Directorate, to CMLRE. I left all my established projects, manpower, labs, everything, and started a new career in the CMLRE where nothing was available at that moment. And then all those years, now 15 years passed, sir. All the biogeochemistry I could able to establish it from CMLRE, where I was doing only that coastal biogeochemistry and then inland ecosystems. Now I could able to do it more in the west coast and then east coast also in the open oceans. And it is all that whatever the output we could able to brought out. It was the support of what you have given, the motivation and then inspiration those days. And then when I was having a difficult times, also you are always behind us and then made a backbone to us. And that was the things we learned also how to survive in a state that when the things were not in your support, but then how to move on. So it was really a lesson, and then achieve all those things. And then today also, last 3.5 years, I have been dealing, leading this center with all that, things, looking all the times. Like when the secretaries, various secretaries were, seeing, when director center has got a lot of, how much a secretary at a ministry level. So obviously, I will feel that the problems at are minuscule when compared to that ministry level. So we deal that matters at our level, and then many times I used to approach you also, sir. Whenever I need a trouble or some issues, a positive response. The same is subsequent Dr. Ravichandran also. He has been kind enough to give all the things, and then Shailesh ji as a Padma Shri is in fact award to all of us, being that MOS family members, and similarly is nothing less to that, and we are always there with the guidance and then thing. And then last year we had one national workshop on Ocean Biology Ministry we conducted. You came here and then gave us so much of insights on what would be that white paper that we had to brought out, and then it has really come up very well. That the final printing is only printing, but rest everything has been finalized. So maybe in a month's time I would be sharing the copies with you. Everything I have already taken some preface also. And thank you very much, sir, and for guiding the entire MOS family, not only that similarly, and your visionary knowledge on wide spectrum of subject and from the to biology. In fact, it's very rare. Some of very rarely we see that a man having that much of wide understanding, especially the biology is something which is not a cup of tea of many people, but then you have with a very thorough understanding it, and then formulations of the project are also have been given by the thoughts, deep thoughts from your insights. Thank you very much, sir. Thank you very much.
Thank you, Dr. Gupta. Can I please invite Dr. Mellot to say a few words?
Good evening, sir. Respected Shailesh Nayak, sir. Sir, we felt when we heard that actually you become Padma Shri, because that is something which we have been waiting for a lot of years now. And the kind of positivity brings to the kind of, any place you meet him, that's what make him so different. Because if you look at the NCPR as a growing actually from a simple Antarctic institution to an institution which has become truly power institution, I think he was very instrumental in that, because the way he promoted us, the way he pushed us, and he kept on, encouraging when we were saying, sir, there is no so much, only little manpower with us. He said, manpower will come. Unless you take big projects, manpower will not come. So when he pushed us to even Himalaya, all the way to climb the Himalayas, I still remember I was arguing with you, sir, actually we can do it, but do you think we have the kind of resources? But come, just you take up again the way I think it has grown now. I think I keep telling him, the Himalayan Cryosphere project actually, we were with a lot of hesitancy we had taken up, but the way it has grown, it's all vision actually. So I think, the kind of visionary he is, he made us to get into so many areas, like when there was a problem with some other projects with some other institute, actually he brought out that projects to NCPR. So therefore, whether it's polymetallic nodules, whether it's sulfides, all including ESS, all lot of projects he pushed to NCPR because he just believed in people. He just believed in people. That the best thing actually that he believes in every youngster. Wherever you see actually, he remembers his name, he pat his own back. I think that gives a lot of positive energy to each one of us. That's why whenever we see you, sir, anywhere and everywhere, we feel that warmth. So we felt so proud that you are now a Padma Shri. Thank you so much, and keep blessing us and keep supporting us. Thank you so much.
Thank you all the dignitaries for the kind words. Dr. Nayak, I have one anecdote to share from my own life. In 2005, when I started my PhD, my then guide sat me down and he told me, Anup, there are two types of scientists. You have foxes and you have hedgehogs. Hedgehogs select a topic and they burrow into it, whereas foxes move from one topic to the another. And both of them are necessary, but you have to select what type of scientist you're going to be. Now, after hearing all of this, I can call him back and say, no, you can be both in one single career. Thank you so much. With that, can I please ask our Secretary, Dr. Ravichandran, to felicitate Dr. Nayak?
Actually, I don't want to miss because of the, my DGM is not there. So on his behalf and IMD's behalf, I take this opportunity to congratulate Padma Shri Shailesh Nayak Sahab for being getting this, this important Padma Shri. See, my association with him was actually during long range forecasting when I was coming from Pune to brief him about long range actually. So I still remember this in 2014 and 15 when we had actually the very drought type of events. And you may be aware that 2015, there was only, after 2014 drought year, the probability of having climatologically second consecutive was only 3%. And I still remember when we had a interaction in IIT, many of the senior scientists were not actually not agreeing even to give a drought forecast. But actually he supported IMD's forecast to go for a deficient monsoon. I think that was one of the first, after several years, IMD had given a successful and correct division, and he supported us to go with those kind of, remember. And similarly, his contribution for the ocean and other thing, I will say that the monsoon mission project, actually, it came during his time, and that is the basis for the current seamless forecasting dynamical system in IMD, which has actually helped to be as a backbone for all kind of services that today IMD is providing and all that success. So once again, for all that support that you have given to IMD, I once again congratulate and thank you, sir. Thank you.
Thank you. I'm sorry, can we please hear from Dr. Sukanta Roy also?
Thank you. Sir, on behalf of all the staff members of BGRL, Karad, past and present, those who are here and those who are not here, I want to convey our heartiest congratulations to you on this momentous achievement. Sir, it's been 10 years, and those few words in your famous baritone voice keep ringing in my ears. Sukanto, you have to leave your comfort zone. 5 words. And then I thought myself, I was happily settled in Hyderabad and I was doing very well. And I hear this from none other than Secretary, Ministry of Earth Sciences. And I just asked myself a question. Okay, if I continue what I'm doing, what am I going to do? I may be writing another 25, 30 papers, maybe 50 papers. But here, I had an opportunity to actually do something new. And I thank you, sir, very much for giving me this privilege and my colleagues this privilege of being associated with such a wonderful program, which I think is one of the top programs in solid earth geophysics, solid earth sciences. So, the moment I came to join ministry in New Delhi, I met Dr. Nayak at 11 o'clock, and I said that I'm here to join. And very, very calmly, in his own usual manner, he said, yeah, you go to Karad. So by 3 o'clock, I was in Karad. And that's all he said. And I knew, as my previous speakers said, that what is freedom? You have the freedom to do what you want. He gave the freedom to do what I really wanted to do, how I wanted to chart the course of BGRL. And then fortunately, as everyone knows, with the help of NCPOR, we got started. And I think we have now traveled a long way. And we have gone through ups and downs. But overall, it has been a really pleasant journey. And I must thank you, sir, again, for giving that wonderful opportunity in the beginning. I really don't want to take more time today because I think there is a function. So I can go on and on, but once again, hearty congratulations.
Thank you, sir. With that, can I please ask Dr. Ravichandran to felicitate Dr. Nayak? For this felicitation, we have the customary shawl, the citation, and also a very carefully selected idol of Ganesha. And this has been selected because Lord Ganesha is known to be the symbol of wisdom, intellect, and removing obstacles, which is basically what Dr. Nayak has been doing throughout his entire career. Thank you, sir. Now we'll be moving on for the Earth Day special lecture by Dr. Shailesh Nayak. As you are all aware, today is the Global Earth Day. This day is celebrated not only to honor our beautiful planet, but it is also a call to action for individuals and communities worldwide to contribute to a healthier, more sustainable environment. We celebrate this day to raise awareness about the importance of protecting our planet's natural resources for future generations. Today, we are all lucky to have Dr. Shailesh Nayak give us the Earth Day special lecture. He has been working throughout his entire career to advance our knowledge of the Earth and the underlying processes that help it function. Please welcome him with a round of applause for this lecture.
Just move it to myself here. Good evening to everybody. And first of all, my greetings to all of you on the Earth Day. And I must really say that I'm really overwhelmed by your love and affection. And I must say that whatever I got is only because of Ministry of Earth Science and the various institutes where I worked. And of course, my initial years at the ISRO. But the real credit goes to Dr. Ravichandran, who has been supporting me for this. Many of you may not be knowing this, but I thought this is secret, let it be out today. And of course, he said that it's not Ravi himself, but he said all Ministry of Earth Science really feels that this should be happen. So I must thank all of you for this honor which I got. And I agree that it is because the work which all of you have done, I'm only some kind of a representative to receive it. The Earth System Science, and today when we are talking about Earth System and on the Amrit Kaal, it's a very difficult task that what we should be doing for next several years. So what I did is I tried to see what are the issues and where Earth System Science can really help. So I will start with which all of you are quite familiar, that we view Earth as a single system with a different components: atmosphere, hydrosphere, biosphere, geosphere, cryosphere, and the interactions which are taking place between them or within each system. How the mass and energy is transferring from this system, and that we try to understand and then model. At the same time, we also try to see how the human influences interact with these processes, or how these processes affect our own activities. So in short, this is what we try to do. But at each stage, the time and the space domains are quite different at different levels. But basically we try to understand all these interactions. Now, how the word Earth System Science came. You know that early it started with mostly by the geology, who talked about large-scale processes of mountain building on origin of oceans and those kind of things. Then later in 19th and 20th century, the biosphere, the functioning of biosphere became very critical, and biology as a geological force was realized, And that is why we get diversity of life. Even today, in the Karad, where we have a drill well up to 3 kilometers, you will be surprised to know that the Deccan basalt has a different microbes than the granite basement has a different microbes. I don't want to go into details, but the role of biology is very critical in the Earth system science. But in 60s, when the satellites came, when we started seeing the Earth in a synoptic way, in a different multispectral way, which I cannot see, and in repetitive way, from one day, 15 minutes nowadays, to 1 month in a different resolutions, which allowed us that many of these processes are regional or a global. And with advancement in computing, we started assimilating those observations and started giving the forecast. So Earth system science is not it's a very recent science. It came in 90s, actually, this word. And the issue that last 30, 35 years, it was realized that this is very important. And the first country who realized that Earth system science is India and set up a separate ministry for Earth science. And that is why you can see the kind of advancement which has happened in last 15 years has been tremendous. So when we look at the Earth science, of course, the ones is a science, but at the same time, the space has a very definite role. So with the Earth science, with the space science, also technology and engineering, but of late, we also look at the social science. Shri said that we always try to see that how this is useful to the society. And because society is evolved, the economics came into this, and also the cognition, that is how we think. So all this together makes the Earth system science. And that is why it provides you a knowledge, insight, or understanding about the Earth in which we live. And that is why it's why we need to preserve or protect is coming, because we understand that how the Earth is functioning. So Earth system science has a very definite role in sustaining life, or what we call as sustainability. So when we talk about sustainability or the sustainable development goals, if you see very closely, you will find there are science-related things, then there are social system-related, and the human system-related things. I'll come back on that later, but basically, it is integrating science. Now, there are certain very important aspects. There are many important, but there are 4 are very critical. One is the variability. Many of the processes, modes and variabilities, is beyond our experience. That means might have happened 1,000 years, 2,000 years, 5,000 years, 100 million years, or even beyond. And that understanding of the past is very critical for us when we want to project the future. So because we need to understand that what happened in the past is very critical for us to understand. If you see this, I think Manish is here, the monsoon, which we talk about, started around 3.2 to 2.8 million years ago in mid-Pliocene, where the climate was more or less similar as of today, including carbon dioxide was around 400 ppm. So the understanding of the past is very critical. The second, of course, I mentioned about the biology, very critical role in the functioning. So biology is second. The connectivity, the processes which are connected ways and across the depths and the lateral distances. We are talking about how the Arctic is affecting our monsoon. So this connectivity with the different types and also at the depth, what you do on the surface, like what you do on a construct a reserve on a surface, which can bring the earthquake down below. So there are different kinds of connectivity which has, and we need to understand that. And the most important that all the processes are a very strong non-linearity. That means any small change can, in the forcing function, can bring, if they push the system beyond the threshold, like what we are saying that 1.5 degree or 2 degree. Why that threshold? Because that's a very small component. But that small component can dramatically change and can bring catastrophe if you cross those thresholds. So these are the 4 features which we should keep in mind when we are planning for what we should be doing for next 25 years. Now, what are the major issues today? One, of course, weather and climate variability and the change, which is, we are talking everywhere, and the entire world is talking. Hazards and the risk. Living resources and ecosystem, we are in 2050, the world population likely to be about 9 billion. So we have to feed them. So the living resource ecosystem. Water is going to be another major area. And you need energy and mineral because that's another important. And what happens in the polar regions. Now, all this are the important. The 2 things are very critical. One, what kind of observations we need and what kind of a technology which we'll need to address these challenges. So first, weather and climate. The Holocene period, that means last 11,000 years, the climate, as we geology call as a stable, is around 15 degree centigrade. And that is the time when the civilization flourished. The Meghalyan age, that is this Holocene has been divided now, that is 2250 before Common Era. That means roughly you can say 5,000 years before. There was a huge drought. It continued for more than 200 years. And the evidence was found in a cave in a Meghalaya. And that is why it is called Meghalayan age. So within this stable 11,000 years, there were changes. And the first major change was the initiation of Meghalaya, and that is where the Harappan civilizations were lost. Then the medieval warming, where the sea surface temperature was more than 2 degrees above today, between 1,000 and 14,000 Common Era, we have witnessed the mega droughts and a very strong monsoon, and the Mayan civilization collapsed because of the huge deforestation because of this drought. So how the climate is affecting the different civilization, we know. And then during Little Ice Age, followed by the Little Ice Age between 15th and 19th century, where the monsoon was lowered and there were a lot of agriculture and economic decline, especially in Europe. And that is where the Europeans started moving out and we got colonized. Not we, many other countries got colonized during that time. And if you see last 150 years, what you call as the industrial age, we all know that the temperature has increased. Now, what we need to do in future, there are so many work done on the understanding about the paleoclimate in all areas, in India, in Arctic, in Antarctica and all. But we don't have a synthesis that each publication, we say this is what happened, but whether I can normalize across the subcontinent and say that 5,000 years before this was the climate, this was the climate. Because the climate is not going to be uniform across the whole subcontinent. And this synthesis, I think, is very critical for us to do, which will allow us to understand what we should do in the future. Now, a lot of work done in IITM, and we know that in coming years, the increase in temperature and moisture which definitely will have a more variability in monsoon, both in mean and extremes, as well as interannual precipitation. And this we are experiencing. This is nothing, is already we are experiencing. We have also seen the number of rainy days has increased in the northwest, and it has a significant, you are now getting floods in Rajasthan and Kutch and Saurashtra. And the total increase is around 8% or so. We also have recorded the increase in the productivity in the northwest and the decrease in the rainfall in the northeast. So this is another area which we need to understand. Also the rivers, the Indus, Ganges and Brahmaputra, likely to have a reduced water supply. Of course, there are, I would say, not 100% consensus on this, because there may be overall may be reduced, but there are also possibility of floods and droughts in the whole country, and the severity of droughts, the area which is covered under drought, and the frequency of a drought is also likely to increase. At the same time, we are likely to get more floods and also. So both the sides are likely to happen. So what we need to do now is we need to have the impact of these kind of a changes on the economic system, on ecosystems, and the human health, on the built environment. That specific area, how it is going to, and for that, we will need a very high resolution regional models which can exploit the specific phenomena. Because if we try to do everything, it is not likely to work. So we need to focus that, okay, what is likely to happen to health or to ecosystem, and if these are going to change, what is likely to happen economic system as well. And the same way, we also need to project this at the local level, because then only we would be able to plan the adaptation measures. And some of those things we already are facing about human health, heat and cold waves. We have the disease, vector-borne and waterborne disease. So there is a need for have an early warning system. We do provide certain advisories, but we still don't have the early warning systems. How the food is likely to be affected, how the drought, especially the drought is very critical. Today, what we do in a drought is we know about meteorological, hydrological, agricultural droughts, but we are not linking to the social systems, that how this change is going to affect the society. So we need to build models that how this drought is going to affect the people. And that is where I think the major challenge is. Now, one of the major thing which is we have been doing, the agromet advisories, we know that it is extremely important, especially in the dry land, and the farmer income depends on the how good advisory we can provide. We had done some experiment with the support of Ministry of Earth Science, and we found in the North Karnataka, basically dry land area, that it definitely helps to pigeon pea, soybean and bird millet. And that is where we realize that this kind of an advisory would be extremely useful for building resilience against the climate change and the income of the farmers. So these advisories should be not only used as a short term, but it's a great instrument in our hands how best adaptation measures can be planned in the future. Now, the good enough word I have used, the decadal forecast anyway we have been giving, but this is, I think we need to improve upon that accuracy, because we need to build new crop varieties, how to plan the irrigation, how to even plan various processing hubs and where we should do. So a lot of activity would be dependent upon our decadal forecast. Also, we also need to do a integration of a crop and climate models. Now the crop people are working separately and the climate people, I think we need to integrate them to sit together and say that how we would be able to understand. Actually, we mostly talk about the temperature, But the carbon dioxide itself is going to affect several crops, especially C3 crops would be severely affected by it. So how do we use our information along with the crop related information and provide that what should be the policy to address this issue? The air pollution is another major area which we have to see. Is one, of course, it has a short term, but also it has the implication on the energy use and the climate change. So we need to build some kind of a framework that how do we measure in a airshed wise, like what we do in a agroclimatic zone. Similarly, here also we need to do airshed wise and see that how we can do. And one of the most important aspect which, in my view, we have not paid enough attention to the atmospheric chemistry. And I think this is a time now that we build very specific actions, what we need to do about this, because there are several changes and also it will affect monsoon and several other things. So this is an area which we need to address. Now, if you don't do all this, right, today there is no way we have telling people that how to adapt to a climate change. So what is happening in our study is what we call as a autonomous adaptation. That means how the individual and the communities respond to the effect. And it's not necessary that what they are doing is the right thing. Many things are happening, like the shoreline erosion, the fish are migrating. In Kerala, during the paddy fields get flooded during the high tide. Now, how do we address this issue? This is an area that before people start adapting themselves to the changes, I think we should come out with the adaptation measures. The water is another major area. And you know that our population has almost become 4 times than what we had during the independence. So the per capita availability of a water has reduced drastically. And we also know that the changes in the rainfall pattern, along with the changes in the sea level, they affect the shallow groundwater table. Because this is very critical to maintain the baseline flow in the rivers, crops, and for the terrestrial ecosystem to survive. We don't have any information today on the shallow groundwater level, how it is being affected. So this is an area which we need to do. The second is in Northwest, the Indus Basin is mostly fed by the snow melt. And we don't have very reliable information what happens in the entire basin as far as the snowfall is concerned. And this, the 25% of our food is coming, and the Pakistan is almost 100%. So the Indus Basin, I think we need to focus on that what is likely to be a water availability in coming years. Now, as you know that these changes will bring changes in the entire water cycle. And so what we need is some kind of a freshwater availability, a census for a given grid, that what is the quality and quantity of fresh water available, what are the needs of people, the ecosystem, and the biota for each grid. I think it's a huge task, but I think we need to have that kind of an accounting system, that which are the areas which are under deficient, which are the areas have a more water, so we know exactly how to transfer water from place A to place B. And of course, we have been seeing now that the many infrastructure projects, which is designed based on the past 40, 50 years data, are not functional. So what we need is much more advanced or continuing developing the sub-basin level hydrographs and large-scale rainfall maps, because the things are changing, and I think we need to continuously update this. Hazards and risk is very important. We have done extremely well in cyclones, tsunami, and many other hazards. But the earthquake is still an area which we have not understood fully. We know that the next earthquake most likely, as most will, comes in the central seismic gap, which is Himachal and Uttarakhand area. Because this area has not ruptured for a long time. We also know from GPS measurement that there is a lot of strain has accumulated. So we need a very coordinated program with all the countries in this region. If you do only in your region, it's not going to help. So right from Nepal, Bhutan, Myanmar, China, Pakistan, we have to find a way to address the issues on the earthquake. The other thing which we need to do is the earthquake is one, but the many geoscience issues depends on what is the structure and composition of the lithosphere. There are several studies done at NGRI in many universities, and Chalapati Rao also has been doing extremely good work on that. But we don't have a complete model of Indian subcontinent. So we need to have a synthesis of all information available, where are the gaps, and then build a system where we can have the tomographic model, starting with Himalaya for the entire country. The dense network of GPS, GNSS works to measure the strain at the plate boundaries. And of course, the satellite has not been launched, but it will be launched sooner, NISAR. We need to know the strain everywhere. What we assume that the earthquakes are likely to happen at the plate boundaries, which is true, but we also have cases where earthquakes happen within the plates. And for that, we need to monitor continuously strain at each and every point. And that is we can do with the SAR interferometry. Also, we have not been used effectively the satellite-based measurements of the magnetic field and the gravity. And that also needs to be done. And the most important, and what we learned from the Koina experience, that we need about 5 to 6 deep boreholes, 3 to 5 kilometers deep, at 5 to 6 places. Of course, these places can be decided, but in my view, it has to be in Indo-Gangetic Plain, and then north and south of the Narmada Rift, and north and south of the Palghat Gap, and in Andaman and Nicobar. Now, this is an area which I think our understanding about measuring various things in the borehole is very limited. And this, I think we need to do, and these programs needs a long time, 10, 15 years of a measurement to come at a right. But I think we have sufficient time, and this thing which we need to do in future. The other major area is the sea level rise. We know that the sea level is increasing in many places. The human settlement and coastal environments are affected. Many places the salinity has also. And why this is important, it is most people believe when the sea level rise, it is just inundation. But it actually leads to many hydrogeomorphic changes. The tidal prism, the tidal level itself gets changes. The sediment transport system changes. Now, how these things are going to affect the low-lying areas is very important. The program on the routinely monitoring shoreline is already on NCCR, but this we have to integrate as a digital shoreline system along with the 3D and 4D hydrodynamic modeling to understand what exactly is happening. And this is, I think, is very important. We have a long coastline and a lot of investment is going today on the Indian coastline. Living resources, we know that our marine fisheries, I have just picked a few examples, not in total, and the fish landing vary between 2.7 to 3.8 million tons. Now, this variability depends on physical, chemical, and biological systems and our understanding. So we must start now this stock assessment of the commercially important species annually as well as the short term, like what we give for wheat and rice and many other crops, that this is what is likely to be produced this year. I think we should say this year we are going to produce this much sardine, this much mackerel, and then can be integrated with the PFZ to see that how the fishing should be done. And I think this is very important for us to do the stock assessment of the commercially important species. Also, we have seen that the increase in this SST, the nursery grounds have been shifted. Also, the shifting of the pelagic fishery is also happening. So how do we model this northward shifting of the fishery? And deep and distant water fisheries, CMLRE has proved a huge potential. But we also need to build the technologies on the harvesting, post-harvesting, product development for all that. So only having the information is not going to be enough, but we need to build how that information can be utilized. Now, the second important thing is that the ecosystem, as I told you, is likely to be affected because of the sea level rise and many other things. What likely to be get affected? We know that the provisioning service, that means the food like fisheries, we have some understanding that this will be get affected. But we don't have that what will happen to sediment transport or the wave attenuation, what we call as a regulating service or supporting primary production, secondary production, carbon sequestration, the cultural service, what is likely to happen to all these services? So we need to understand the changes which are coming on the various ecosystem services. Also, the program has already been started that we are measuring the ocean biodiversity. Also, I understand coastal also has been started, but we need to have a regular update, say every 10 years like our census. So we know that how the things have been changing. And of course, we need to go for coastal marine spatial planning. Already some examples in Pondicherry and Lakshadweep have been done, but I think we need to scale it up. How do we do it for the entire country? What policy interventions are required? The other is the economic value of the service. I told you this in Earth system, this is very critical, like mangroves. It's a huge benefit. Somebody has estimated as about $3,300 per hectare per year. Similarly, for the coral reefs, the huge value. Now, we don't know that how to identify the economic value, and this is where we need to interact more with the social scientists and economists to find out that, okay, what is the value of protecting a shoreline? What is the value of a sequestration, carbon sequestration? What is the value of different services, production of primary and secondary production? Now, this in similarly for coral reef, and coral reef, it is very critical. Now it seems that the fourth bleaching event has started. Shri may be knowing and providing services. But can we give a pH values at different IPCC scenarios? Can we say that this is likely to happen if we continue? Maybe difficult, but I think the attempt has to be made. And then we know that what likely impact it would have on the biota and then on fisheries. So, sorry. So this is very critical for us to ensure the food security for us. The next is the energy and mineral. One source, the gas hydrate. A lot of work has been done, and we know that there is huge potential available in the both east and west coast. What we have not done much is how this gas hydrate has been forming and what is the technology. I understand NIOT has some numerical models started, but the technology, ONGC, I understand, have a research center in Bombay and they have been, but we don't know what exactly is happening. The problem is this gas hydrate is a solidified methane gas, occurs as about 2,500 to 3,000 meter. And because of the pressure, it remains solidified. Now, if you want to harness and if you bring it, it may escape as a gas. And that could be further aggravate the situation of a climate change. So this is a very useful problem for us to address, that what kind of a technology which we need to build. The next is the various energy resources we have been talking about, maybe gas hydrate, shale gas, geothermal, renewable, nuclear, vis-a-vis fossil fuel, and how it is going to affect the carbon dioxide level or land use. We say that it will all reduce, but how and how much? Because ultimately, whatever you do with either renewable or not, there are certain material use that waste is also going to be disposed of after a few years. So the end-to-end for the energy transition, we should have a clear idea that if I shift from X to Y, this is what going to happen. And once we have said that we are going to be more dependent on the renewables, the three things are very critical. One is the lithium, cobalt, nickel, and manganese. Now, if you see the world resources of nickel, cobalt, and manganese, the requirement would be 500,000, 250,000, 25,000, and 39.3 million tons in coming years. As of today, whatever this demand cannot be met by the land-based mines. So it has to be seabed mining. And I'm sure that Ministry of Earth Science has taken a lot of initiative, and this is, but I think one is we know what is the potential, and second is mining is quite challenging task. And this is where I think we have to put a lot of resources that if we have to mine, how do we going to do that? Rare earth is another major area, and this is, we have to identify the areas where it is available. We don't have much of the rare earth. We do have, but it is associated with the thorium. So if you want, and we don't know how to use thorium yet, so you can't go on generating thorium and keeping piling. So we have to find other resources of a rare earth. And the initiative taken, I think, by Tamban to go to Greenland, I think it's very important. We have to go to outside areas, high seas and other, to look for where the rare earth available and how do we get an access to that. The polar region, of course, we know the Antarctica is extremely strategic, and this we have to continue to build our presence there. There are many areas which we have been working, especially working on our modeling of weather, climate, ecosystem, paleoclimate, teleconnections. Southern Ocean is, we need to continue our studies and impact on climate change. The other aspect, two aspects which are very important is the tectonics, dynamic topography, and the fragmentation of Gondwana and Praktaka. This is where area I think we need to put some more effort to see that how do we further enhance our efforts in this region. The one thing which is, there are many biota, but I think what is the vulnerability of penguins? I mean, whether any study we can take it up, whether they are going to be as it is with the change or there is going to be any impact. I think then the many other biota, I think some discussion on this is required to be done. And the Space weather is going to be very important, and what is likely to happen to polar ionosphere. I think this studies is going to be very critical. Arctic, of course, we know that we have been now that the cold episodes in the North Atlantic has weakened the monsoon during Holocene. This has been recorded and very well established. Same way, what happens in the Northwest Himalaya also affects the Canadian Arctic. So we have stations now, I understand, Canada and Norway, but I think we need stations in Greenland, Alaska, and everywhere, even if possible, Finland, Russia, because this is very critical for us to understand what is happening there. Not only that, also our presence is required there for access to the oil and gas, for the critical minerals, to the shipping route, and also the satellite receiving stations we have in Antarctica in our, so that we are receiving about 9 orbit. By putting in Arctic, we will have about 10 to 11 orbit. And combining this both, we have a global data in a real time of the high resolution. This is, I think, is very critical for us to continue our presence in Arctic. Now, the Himalaya is one which is, we know that there is going to be issues, that most of the studies said the glaciers are receding, but that's not enough. What is the Earth system science? We are interested in the mass change. And the change in mass is not well known, except in few selected glaciers. How do we scale it up that we know that the mass change in the Himalaya is this much? We know that there is a study, the GRACE data showed that mass loss of 4 billion tons annually, which is very high. Now, if such a large mass is being lost, what is happening in the geology we call as the glacio-isostatic equilibrium? Is there any change? Is there anything happening in Himalaya because of that? We need a very close network of geodetic network to understand that if such a large mass is changed, what is happening to the Himalaya? So what we need is a regional study of the snow and glaciers. Extremely good. In Chandra Basin, we have shown the Himans, what should be the ideal. But this kind of a system with completely automated system, long-term observations on all aspects, geology, geophysics, hydrology, atmosphere, in all the basins. Now, how do we scale it up, this model? So that is a question. And then once we have, then how this information can be used for the basin-wide studies. How we can use this information for building early warning systems for landslide, avalanches, globes, and many other things. Now, the one concept which is already accepted, the Himalayan Science Council, but I understand it is not much moving on that. Why it is very important, if you see 25 years back when the IO-GOOS was started, the same feeling was there at what it can. But today IO-GOOS has done a lot of things. And I think there may be hurdles. I'm not saying it is going to be that simple, but I think India has to promote the Himalayan Science Council and networking all the science institutes in this Himalayan region. At least don't do anything, at least talk what they are doing, what is happening. Like what happens in Nepal is going to affect us. If the deforestation occurs in Nepal, it's not Nepal's problem alone, it's our problem also. So I think we need this council to be very active and at least once in a year to start meeting of all science institutes. It doesn't matter if China doesn't come or Pakistan doesn't come, but if Bhutan comes, or Myanmar comes, or Thailand comes, or whoever comes, I think we need to have this. It's a beautiful document is available, and I think this we need to pursue. Lastly, what we talk mainly about this Earth system knowledge. But Earth system science also needs to understand the social system. What is the governance structure? I'll give you a very small example. We all agreed for the Paris Agreement, all countries. But when President Donald Trump walked out of the Paris Agreement, of course, when Biden came, they again came in. So the governance system is equally important for us to put our knowledge into practice. That is very important. And second is the human system, or the consciousness of individual also is very critical. So we need to understand all this. Otherwise, our activities which have this kind of an impact right now we are seeing the impact only up to certain level, but tomorrow it can also lead to violence or war or many other things. So we need to start building our model, including the knowledge with the social and this system. Then only we would be able to implement what we all want to do. Now, to do this, we will need a long and sustained observation. This audience knows very well, much better than what I know. But the two things are very critical in this is the biogeochemistry, biology, ecology, and physics. This capacity to build for this is very critical. And I think when anybody comes out of the university, he is not fully trained for this. So I think we need to have a training mechanism to bring this into practice. Timely availability of your observations is very critical. Trace elements and isotopes for the productivity in the oceans. I think this, we should have a continuous program on the measuring this so that we understand that how the resources are going to be affected. And of course, the atmospheric chemistry. We need to continue geological and of also continental shelf. We have restricted ourselves to EEZ, but I don't think we need to restrict ourselves to EEZ. We need to go to continental shelf, the high seas, wherever we think there is a possibility of resources. I think that program we have to continue. So it will need a huge investment in satellites, research vessels, all this kind of thing. And the one thing when we continue to make the observations, the database, I think the INCOIS has already started a digital ocean, but it has to be digital atmosphere also, digital polar also, all together, and then you link them together. Because I think that is very critical for us to make all as a digital earth, so that all things are available, then only we would be able to understand the different interactions. These are some of the observations. I think I won't go into the details, but the one is wind profiling is very critical, whether you do through aircraft or a satellite or whatever, because it has been realized that the wind is more critical for us than the property of a mass or a humidity or a temperature, which we are able to measure, but the wind measurements are very less. And the humidity has a higher resolution for the using microwave. Also, we need one which is very critical, that sea surface temperature during monsoon is not very good. And this is a very simple instrument which we can make. A beam size look and make. It was flown in OceanSat 1. I don't know why it was discontinued. It's a very nice, simple instrument, but we get very accurate SST during the monsoon. The INSAR and the other thing, of course, these are the things which is already going. I have not put all those required, but I think the earth science community should sit together and say what kind of observations at what frequency we need it. And of course, technology. I think this is very critical. And we have extremely good institute as far as the ocean is concerned. But we need to develop the sensors and platform for all, the atmosphere, ocean, solid earth. And I'm very happy to see the advertisement of MOES that you have said the accelerometer and seismometer has to be built. I mean, whoever wants to. I think it's an extremely good approach. And I think we need this approach for many other things. The second thing we required, of course, manned submersibles, which is already going on. Also, I have not put here, but a lot of robotics also will come along with the autonomous vehicles, and that is the other thing, which is underwater imaging, which was started in an IoT, but I think has to be pursued with much more vigor. Some initial experiments were done in Idukki Reservoir, and fantastic results came out. Actually, Chalapati, you should see that. We know that the reservoir should always have a mud and sand, but in Idukki we could map beautifully all the fractures. There was no mud or sand on the surface. So what we normally believe is not necessarily true. So I think the underwater imaging is one area which we should pick up. Freshwater from sea we have done very well, but scaling up is required. How to scale it up? Offshore plants, 1 million, 10 million, whether we can do it. Energy, of course, we have a lot of good experiments. Underwater vehicles, many things have been developed, but all are at TRL level 3 or 4. And we need to take them to 8 and 9. Any technology developed, one very good example is the drifting buoy, which is now commercially produced. I think all technology has to go to. Biofuel is same thing. We have a pilot scale plant, but it has not scaled it up. And I think we need to build technology for atmospheric and geotechnology. And if I say that the scope of NIoT has to be increased, I think they cannot do only ocean. Is all technology related for Earth system science has to come, because we need those kind of things. Otherwise, whatever we want to without backup of a technology, we won't be able to go forward. A lot of infrastructure requirement, I'm sure that you all know about it. And this is one area which is, I think, is very important. We need aircraft which can go beyond 15 kilometers to discuss, to understand about how the troposphere, stratosphere interaction. I had some discussion with Krishnan, but I think this is an area which is, this all, I'm sure that we are doing. The other thing which we are missing is the offshore numerical tank. I think for simulations, we will need this. And of course, these are all known, AI driven and quantum and all is in the, but these two, I think, is very critical for us. One is this and other is the aircraft. The most important to do all this in Amrit Kaal, you need appropriate governance structure. And I think most important is the Earth Commission. And how to operationalize, I think, is very important. Once that is operationalized, I think the remaining thing, this also will be automatically come into picture. The training school, I think this is an area which is very important for training people, especially in those areas which are not actually taught in the university and which we need experience. Also, we need to set up a public sector company, maybe called Earth Corporation or whatever you want to call. The collaboration is very critical. One with ISRO is very critical because the observations, our most observations are likely to come in future also from satellites. And already I understand Earth Science is paying for the satellites now. So we have every right to have what kind of satellites are needed. The networking with the other research institutes, universities, ISRs has to be much more enhanced. Also foreign research institute universities and also with social science and humanities. Because whatever we do, how it is going to impact the society, also we need to know. And of course, I'm extremely grateful to all of you because whatever I have been talking about today is essentially with many of you, formally, informally, we have discussed in one way or other. So I thank you very much for this opportunity and the honor which you have given me. Thank you very much. Thank you.
Thank you, sir, for this very comprehensive and informative lecture, and also for detailing what all is necessary to actually improve the earth sciences that we are working on. With this, we thank everyone for joining the Earth Day special talk and also for the felicitation that you were able to see today. We will now take a 10-minute break. There are some snacks which have been organized outside in the lobby, and then we'll congregate over here for the cultural program. Please do not miss the cultural program because we have a really nice performance by the Bal Kalyan students who have already arrived over here. So please take 10-15 minutes and come back. Thank you.